Go.
All right, we're going to do a pH tube today, and I have a universal indicator in here, and it's kind of a yellowish color. I'm hoping you're able to see it out here. We got some mixed lighting, but probably better than the indoor lighting. And I'm going to add some HCl, some 0.1 molar HCl to this. My tube broke, so I had to put a little duct tape on there. Okay, and we can see what's happening to the color there. At least to me, I can see it's getting red up on top inside of this yellow. I put this cap on and flip this over. You can kind of see the red climbing up through the bottom. There goes the air bubble through it. And I'm going to take this top off. Hopefully it's not going to leak too bad from the bottom for me. And I'm going to add some NaOH. Okay, I'm going to add that. And I need to find the other part of this tube, and I don't know where it went. So I'm going to flip it over like this, and we can start to see that we have red up here, and it's yellow, then it gets to be green, then it's more of a purple down here. Oh, I think I'm finding, I'm going to flip it back over. I'm finding my rubber stopper, put this in, moving a little bit out of the water out of the leaky end. You can kind of see what's happening. We're starting to mix the acid and base together. But where I added the straight base right here, it is, or straight acid right here, it's more acidic. So it's got, it's more acidic here where it's red, where it's dark blue, it's more basic. Right about in the middle here, it's going to be a neutral pH. That'll be a pH of 7. And what's happening as they intermix, you're going up pH of 6, 5, 4, 3, probably around a 3 or a 2 right here. Not too acidic and very dilute, so if I'm getting this on my hands, I'm not worried about that. Same thing with the base right here. I'm at 7, and then as I go down, 8, 9, 10, maybe about 12 right here, pH with these dilute solutions. In case it leaks, I'm not worried about that right there, but we can see this different coloring. Just something about the pH scale, a neutral pH is 7. If you have a pH less than 7, it's acidic. pH greater than 7, it's a base. pH less than 7, you have more H plus than OH minus. A pH greater than 7, you have more OH minus than H plus. So what's happening here is, what about if you have a pH of 4 compared to a pH of 5? pH of 4 would be 10 times more H pluses than a pH of 5. pH of 3 versus 5 is 100 times more H pluses than a pH of 5. pH of 2 versus pH of 5 is 1,000 times more H plus than a pH of 5. And then if you look at this in the other way, if you have a pH of, a pH of 10, if you go to a pH of 11, pH of 11 has 10 times less H pluses than a pH of 10. 12 compared to 10 would be 100 times different, and 13 compared to 10 would be 1,000 times different. So the pH scale is really a logarithmic scale based on, really, the pH is the negative log of H plus. And that's what we're going to look at when we do this right here. Okay, ultimately, if this thing turns and mixes around, it'll probably blend and be neutral, assuming I added the same amount of acid and base to this, and it's going to come out and balance out, but it'll take a while for it to mix. Let's just look at this equation. Let's see, H2O breaks up into H plus and OH minus. This is a dissociation of water. Does it happen? Yes. Does it happen to much of a degree? No. For every 50 million molecules of water, one of them breaks up into H plus, one breaks up into OH minus. So, we have a equilibrium constant value for water. It's H plus times OH minus, or the H2O liquid, and it's a really, really small number, 1 times 10 to the negative 14th, meaning the vast majority of H2O does not split up. It's a very, very small amount that breaks up into H plus and OH minus. Yet, that amount of H plus relative to OH minus, H plus being the acid, OH minus being the base, really tells us about our pH scale. We'll do a specific pH calculation video where we'll be looking at that, and just wanted to give you a visual to look at. Thank you.